Hi, everybody. Konnichiwa. All right, welcome to Inline RBS comments for seamless type checking with Sorbet. My name is Alexandre Terrasa. You can reach out to me by email, because I don't use Twitter, or on GitHub. I'm a senior staff engineer at Shopify. I'm working in the Ruby on Rails infrastructure team, more precisely in the Ruby developer experience team. You may have heard of us for projects such as the Ruby LSP, Tapioca, which is a companion tool for Sorbet, or contribution to Sorbet. We actually were created, our team was created to introduce Sorbet at Shopify in February 2019, where we were early adopters of Sorbet a few months before it was open sourced. And we realized the need to have type checking for such a large code base. A few years after that, RBS was created around 2021 and for Ruby 3. And this is also around this time that Steep was open sourced. So as the Ruby developer experience team, our goal is to understand what our developers want and what we should be doing for them. To do that, we run surveys every year, and we ask them questions about what are the things that you need. So for example, since we introduced typing using Sorbet at Shopify, we asked them, do you want more code to be typed? Are the types useful for you, and do you need more? And while at the beginning, when we introduced it, it was not very clear if they really want it or not. If we look at our most recent edition of the survey, 80% of them are like, yes, I need more types. This is super useful. The same when we ask them, do you want Sorbet to be used in more code bases at Shopify? They're like, yes. 70% of them are like, yes, this is super useful. If we looked at the beginning, though, that was not that clear. But people came to understand and to appreciate the benefits of static typing, gradual typing. When we ask them, do you want to have to write less annotations in your code? It's not really something that bothered them in majority. 55% of them are saying yes, that would be cool, but it's not as obvious as previous questions. But when we ask them, do you want a friendlier syntax to express the types in your code? 75% of them are like, yes, we need something better. If you haven't been introduced to Sorbet before, let me give you an example of what it looks like. First, we're going to express the signatures for our methods using the sig calls here directly in the Ruby code, saying, I'm having a signature for this attribute reader, for example, or a signature for this initialize. The signature express the params that are used that are used by the method, and I'm going to say that the return type is whatever. Because this is actual Ruby code, this sig method needs to be defined somewhere. And to be able to use that, you need to also depend on the Sorbet runtime gem that defines this sig method here somewhere. And to make it available in your class, you need to extend tsig directly in your class. So this is already a lot of clutter. This is not the most beautiful Ruby I've seen in my life. And if you see this really easy piece of code here, simple piece of code, almost half of it is already type annotations. When we want to express types, we have to go around the Ruby syntax because it's actually Ruby code. So we have to find ways with the Ruby syntax to actually express the types that we have in our code. So for example, here I'm having a label of a location. I can say that my block for my method is optional by having, again, a t.newLabel call, and I'm expressing the block with t.proc. This is getting very painful to write when you have to do that on every method that you have in your code base. We can also annotate the type of instance variables, local variables, these kind of things. And again, we have to go around with the t.let to express that I want to set the type of this variable, and this is going to be an array of node. This is, again, very painful. So we need a friendlier syntax for that. This is not something we like to use everywhere. When Ruby 3 was released, there was a glimmer of hope because it was coming with RBS. That was a new language to describe types for Ruby programs. And we were super excited because we really wanted to jump on this wagon and say, OK, we're going to use RBS now. We can replace the Sorbet syntax by this. Sadly, we did a few tries. And the concept of RBS is you have your Ruby file that is proper Ruby code. And you have a companion file that is the .rbs file in which you're going to express the types that you are going to use in your program. So first problem, it's a lot of duplication. For every file, you have this .rbs companion file that's coming with it. And for us, we have something like 75,000 files in our monolith. 1.5 million methods. That is a lot of duplication we need to do. And imagine opening the pull request to GitHub by doubling the size of your code base. That will not fly. The other issue is that you cannot express types for local variables, for example, in your code, and you cannot do things like casts or setting the type of, I already said it, local variables. So that was also an issue for proper type checking and in-depth type checking. So what we actually really wanted was a mix of the two worlds. We wanted to be in a Ruby file and be able to express the types directly by using the nicer syntax that is RBS, but directly in the Ruby file. And for example, we can do that using comments. We can add a comment on top of the attribute reader or on top of the method saying that here is the type, that the signature for my method. And because I'm in a comment, now I'm not like bound to the Ruby syntax, and I can express using the RBS syntax what is the type of my parameter. For example, I'm having a label of location using this question mark, or I can set the type of my proc by my block, by using this syntax. This is much nicer. And if we're using comments, we also can put them in different places and, for example, use them as well to define the type of the instance variables. Because we use comments, we don't have to support this sig method. We don't have to have any kind of runtime dependency that may add an overhead, for example, when I'm running my code in production. So no more runtime dependency, nice syntax, just comments. This is exactly what we want. So how do we get there? First, we have to choose like a type checker to do this with. Of course, we're using a lot of Sorbet at Shopify. We have more than 600 code bases using Sorbet in our company. So that was a strong incentive to go with Sorbet and continue with it, because we don't want to break like the work we already did. Or Monolith also saw like a lot of a very good adoption. 99% of the files we have in the monolith are using Sorbet and are type-checked by Sorbet. Most of the important methods that we use already have a signature, and more than 60% of the calls we do in our monolith are against a method that comes with a signature. There is another type checker for Ruby that is called Steep that was introduced by Sutaro. We tried to use it. The most important problem here is like speed, because Steep is written in Ruby. It's very hard to compete with a C++ implementation that is highly parallelizable. So when we try it on small code bases, it does work, it scales. We can type check most of what we already had. When we run it against the monolith, something that we can type check in under 20 seconds with Sorbet takes more than an hour with Steep. So this is not something we can run on CI, for example, because we deploy much more often. So that was a problem. So we were like facing two choices here, or we can make Sorbet support RBS syntax, or we can invest a lot of time on Steep to make it faster and scalable. When we looked at the kind of features that were like defined in Sorbet and that we could express with RBS, the coverage was really good. Most of the features we have in Sorbet have an equivalent in the RBS syntax, so we can do the replacement. Just some of the syntax actually existing in RBS does not have an equivalent in Sorbet, so that was not a problem. We can just like forbid it when you're trying to write it. And for most of the features, we have an equivalent. The only problem here was the lower bound on generics, that you cannot express that in Sorbet, but I believe this is something we can change. Sorbet do have a few features that we cannot express in RBS and that will not make sense to bring to RBS. For example, the concept of abstract classes or abstract methods. For those, we will have to find a workaround. I'm going to show you that later. If you want to know more about RBS and Sorbet syntax and the specification behind them, you can take a look at one of my previous talks that is gradual typing for Ruby, comparing RBS and RBI Sorbet at previous RubyKaigi. So let's see how we can start using RBS comments for type checking with Sorbet. The first problem was the Ruby RBS parser. The RBS parser was built around the Ruby VM. So to parse a piece of RBS code, you had to have a Ruby VM running. That means that if we wanted to use this RBS parser from the Sorbet C++ implementation, we also needed to embed a Ruby VM in the C++ implementation. That's a problem, especially when you do a lot of parallelized analysis where we're going to fight with the GVL a lot. So we actually fixed this problem, and I hope you had a chance to see my colleague Alexander yesterday that was explaining how we transformed the Ruby RBS parser. to be a pure C implementation, so we can include it in the C++ Sorbet with absolutely no problem. And from there, we needed to find a solution to use this RBS parser inside Sorbet. So let me give you just a simplified overview of how Sorbet is doing the type checking. We're having this, what we call a type checking pipeline here, where in input, I'm going to give Ruby files, and in output, I'm going to have the type checking errors, if any, that are going to be displayed on my screen. The very first step is to parse the code. I'm having those files that I need to transform in something that is more easier to analyze. So we're going to build an abstract syntax tree from this. This is just a tree of nodes representing the content of a Ruby file. The second step is called desugar. We're actually going to rewrite the AST we got at the previous phase into another AST that I'm going to call simplified, which is going to remove variation inside this AST. Let me give you an example. So in Ruby, I can use a lot of syntactic sugar. For example, I can express the inverse of an if using the unless keyword. And I can say that unless argv is empty, I'm going to call argv.shift, and I'm going to use another syntactic sugar to do a safe navigation and call toI on it only if it's not nil. Desugaring the code is removing this syntactic sugar. I'm going to just find an equivalent way to express the same thing with less variation. So for example, an unless can be changed into an if I negate the condition. And a safe navigation can be translated in just adding an if guard to say I'm going to call toI only if the result of argv.shift is not nil. So by doing this desugaring, we just make the work of subsequent phases easier because they don't have to care about all the variations of the syntax. Once I'm having this simplified AST, I can resolve it, which basically is creating a knowledge base about what is in the code. What are the relationships between classes, for example, through inheritance, or with modules, with mixins, and just keeping track of what exists in the code base and how types are related. Another phase is going to be to build the control flow graph, which is a graph of nodes explaining what is the flow of information in our blocks of code. So for example, I'm having a variable, it's going to go in an if, and in this branch, I'm going to declare another variable, this kind of things. Using both this information, the control flow graph and the global state, I can start type checking the code. I can flow my types in a piece of code and get the type checking errors, if any. To support RBS, what we did was to add a new phase in between the parsing and the desugaring. This phase is here to rewrite the AST we got from the parser into a new AST that has type information that we want to feed to the rest of the pipeline. By doing so, we can just add this step at the beginning, and we limit the blast radius of our change. The rest of the pipeline doesn't have to care about RBS at all. Let me give you an example of how that works. So as an input, I'm having this file with the RBS comments. Please keep in mind, I'm in the Sorbet process. This is static analysis. This is not actually running the code, the Ruby code. It's just doing analysis over the code, not actually executing it. So this is what the Ruby static analyzer sees when it's analyzing my code and trying to find type checking errors. So it's seeing those comments, and what we want to do is to rewrite the code so Sorbet sees it as if it had actual SIG calls inside it. Again, I'm not executing this. This is just what Sorbet is saying. So I'm going to take these comments saying that I'm having an array of node, and I'm going to create the equivalent SIG returns array of node for Sorbet to see it, and so the rest of the type checking pipeline is going to see as I was using SIG calls in the middle. So for signatures, I can express them, for example, for attribute readers and different attribute accessors by the hashtag colon comment on top of it. And for methods, I can use the hashtag comment with the parentheses, the arrow to say the return type. I can also split it over multiple lines if I have a very long line and I want to please Robocop, these kind of things. So we're going to take those comments and translate them into the actual SIG syntax that Sorbet knows for it to type check properly. How does that work? I'm going to take a very simplified example here. So my def_foo method has a comment on top of it that says it returns void, and my attribute reader bar is returning a string. When we're running the parse phase on this, we're getting back the AST, the original AST, and the table of comments that exists in the code we just parsed. Then we're going to visit this AST, and for each node, we're going to check, is there a comment that is related to this node? So I'm going to find my def here, looking that, oh, my def is at line 2. Is there a comment in a previous line that has not been consumed by another node yet? So I'm going to look in my table here and see, oh, okay, yeah, there is a comment line 1. So I'm going to associate it to my def. Then I'm continuing visiting, and I'm going to find this attribute reader at line 5. And line 5, I'm going to look in my table and say, oh, is there a comment that is not consumed yet that is related, that is before line 5? And I'm going to find this comment at line 4, okay, associated. Once I am having this node versus comment association, I just have to do the rewriting. I'm going to change my AST to introduce the SIG calls that Sorbet is going to see as the type checking artifact it needs. So I'm going to introduce a SIG call before def, and I'm going to introduce a SIG call before attribute reader to say, like, oh, here are the parameters and here is the return type. Again, I'm not executing this. This is just what Sorbet sees when it's analyzing the code statically. And so for it, Sorbet is actually just going to see SIG calls in the middle, and it's going to type check it properly. We are actually going one step further. When we created the SIG calls here, we're lying to Sorbet and we're telling it the location of this SIG call is somewhere in the comment. So I'm passing back the location that I got from my table here to my SIG call to tell Sorbet, like, this thing is actually in the comment at the comment location. That enables in the Sorbet LSP, when you hover over something in the comments, or you comment click on something in the comment, all the power of the LSP actually works. And I can hover a type in the comment, giving you, like, oh, here is the definition of comment, and you can see what is like the comment of this comment. Or you can do jump to navigation when you comment click, for example. On top of signatures, we also have inline assertions. Inline assertions are here to define the type of local variables or instance variables, and you can do multiple things with them. You can define the type of a variable with the hashtag colon, the type of the variable after that. In Sorbet, you will do t.let, and then new variable, and finally the type for this. You can also statically cast the type of a variable when you want to change this type. So I had something that was here a node, and I know it's actually a tree, so I'm going to cast it with hashtag colon as the type of my thing. In Sorbet, you will use t.cast for this. And there is a specific kind of cast that is casting to the non-nillable version of this thing. So I just want to remove the nillable attribute from it. I'm having a nillable of node, and I know it's not nil, so I can cast it to as not nil with the syntax, which will be the t.must equivalent in Sorbet. And we use the exact same approach, mapping the comments directly to the nodes when we're going to visit. So outside of so we have this piece of code here. We're going to parse it. We're getting the comment table and the AST, and we're going to start visiting it and find, okay, I'm having an assign. I'm going to look at its return at its value. The value finishes line 1 colon 8. Do I have a comment after this? Just that exists. So I am having one at like the colon 9. So I can associate it with this node. I'm going to continue visiting. I'm finding the call to bar. I'm going to visit the arguments. I'm finding this local variable here that is finishing colon 4 at line 4. I'm going to look at my table. I'm having a comment. OK, I'm associating it. And the same thing for the return value. Finding some at the colon 10, associating it here. And finally, I'm going to rewrite it. So I'm having those nodes with the comment association. And I'm going to introduce the nodes in the AST that represent the calls that I will have to t.let, t.cast, t.must, and using t-nillable and all the apparatus of Sorbet. I can do this comment association with also pieces of expression. For example, when I need to cast, for example, a must in the middle of an expression, so I can split it into multiple lines. Sadly, Ruby only supports end-of-the-line comments with the hashtag. If we had inline comments, that would be even better. If you saw the talk, like the Ruby against the world, Ruby committers against the world this morning, maybe one day it will exist. So if you want to use those hashtag comments on expressions, you have to split your expression over multiple lines. So here I can express that my at nodes, the dot first call, I'm going to cast the return value to a tree. Then on this tree, I'm going to call dot nodes again and call dot first. And I'm going to cast the return of first as non-nillable because I know I have at least one. And finally, I'm going to call dot name on it. I can do the same thing for arguments and split my call over multiple lines to specify the type of the arguments. And here I'm also taking in consideration the comma that may exist and just looking, is there a comment after the comma? You can use those case casts and things directly inside arrays for typing the element of an arrays or typing the values in a hash. You can also apply it to nodes and all the kind of expression we use in Ruby. For the things that do not exist in RBS that we still need with Sorbet, for example, declaring a class as abstract, we have to find another way because we cannot use the RBS comment itself to represent this because there is no syntax equivalent for it. So we just decided to reuse the same kind of RDoc annotations. I can use the hashtag @abstract on top of my class, and I'm going to call generate the equivalent Sorbet DSL for this that is calling the abstract bang method. Same thing for the interface, and I'm calling to call the, so with the at interface, I'm going to call the interface bang method. Finally, Sorbet has this feature that is requiring an ancestor. That means that I can only include the module indexable in a class that descends from a node, and so like a subclass of a node. And for this, you need to call this require ancestor method. We're representing this again with the @ comment just on top of the module. We can also use those annotations on top of methods. For example, when you want to define that a method is abstract, very useful when you're having a large code base and you want to establish contracts with other teams that are working on the same code base than you. In Sorbet, you represent this by calling abstract inside the SIG block. For us in RBS, we're going to do it with the @abstract on top of the method. We can do the override when you're defining an abstract method. We use override in a SIG block in Sorbet. We're going to do that with the @override in a comment. This is still very experimental, but that works. Finally, generics. Again, experimental, but like you can make it work. We decided to use, because there is no real way in Ruby to express what is a generic, we decided to use the equivalent of a signature before a class. So on top of your class or your module, you could do #: with in brackets the types that your generic container is taking. So in Sorbet, we will do that by creating a constant E that calls type member and saying, like, for example, here I'm having an E that is my type member that is having an upper bound to node. I can represent this with bracket E and thus lesser than node in my RBS signature, and that's going to generate the same code here. Again, this is just what Sorbet sees. This is not what you actually execute at runtime. When we instantiate the class, in Sorbet, because we have this runtime equivalent here, when we're using Sorbet runtime, it's going to actually create the bracket method for us on the generic class. And we don't have this anymore. We don't want to run this anymore. So the equivalent for this will be to t.let with the comment here to say my tree.new is actually a tree of node, and I'm happy with this. Then I can use these type members directly onto my methods. So for example, my shovel operator here is going to take something that is typed as a he. And I can type check when I'm calling tree shovel dev.new. I can make sure that dev.new is actually a subtype of my e. Finally, in RBS and in Sorbet, you can also define method generics, where you have a type member that only exists in the context of a method. And here we're doing this with the n, where we're going to define, OK, my method here is taking a type parameter that is n, and it's going to take the class, the singleton class of n, and finally return an array of n. So all that works is my lookup methods expect a type, and it's going to look inside its own tree if there is like something that matches this type. So for example, I want to look up in my tree if they are like def instances, and it's going to return an array of the instances of def. In Sorbet, this is much more verbose. This is what the equivalent we're going to generate. We're calling to type parameters. We're creating a symbol n. It's going to represent my type parameter. And when I want to reference it inside my signature, I have to call t.type parameter with the symbol n here. So that's a lot of changes if you need to migrate your code base from the old Sorbet syntax to the RBS comments. That's kind of painful to do manually. For this, we decided to provide an automated translation tool. We added this feature to a tool that we own that is called Spoom, that is doing a bunch of things around static analysis for code, and also a bunch of different Sorbet-related tooling. So if you run Spoom SRB6 translate in your code base, it's going to translate all your old Sorbet syntax signatures into the RBS syntax, RBS comment equivalent. And we have the same thing for assertion with Spoom SRB assertion translate. Of course, big code base, you don't want to be changing all the signatures at the same time. That's going to be a awful PR to pull requests to review by your teammates. So maybe you want to do this in multiple installment. So for example, you could be just migrating file by file and opening pull requests for this. So I coin this thing that I like to be the gradual typing, where you can still use the old Sorbet syntax at the same time that you're using the RBS comments, and everything works properly. You may have noticed that we also have syntax highlighting for those RBS comments, where we're having like this coloration here, the void as a certain type and stuff. We already shipped that inside the Ruby LSP, and it's already providing the syntax highlighting for RBS comments if you have an LSP that is up to date. And what if you really don't want type annotations in your code? Well, we actually also provided an option in the Ruby LSP where you can tweak the opacity of signatures and type annotations. So you can say, I want the opacity of my type annotation to 0, and it's actually going to make disappear your type annotation. So your colleagues can still be happy, and you can be happy, and everybody is happy, and this is perfect. Of course, using comments has some drawbacks. Let's just cover them quickly. The first one is the type checking time is longer because we need to now parse the comments, and we need to parse the RBS that is inside the comments. So with the prototype version, we were like up to 2 times slower than the vanilla Sorbet. We actually worked on this a lot. My colleague Can has been doing like tremendous improvement to it, and we actually now like very close to having no overhead at all. It's not released yet, but very soon. We also have plans to migrate the internal parser of Sorbet to Prism to benefit from Prism speed. And also we're thinking about maybe migrating the comment parsing and comment association to Prism directly to avoid the overhead in Sorbet. Because it's comments, we don't have any kind of Robocop support for it yet. So no way to enforce spaces, commas, before or after commas and parentheses and stuff. If you want to provide Robocop support for RBS signatures, please do so. That will be super helpful. And the last problem is the loss of runtime type checking. So everything I explained right now is in the static process when you're running Sorbet on your code base, like running SRB-TC on your code base. This is what Sorbet was doing and was seeing, and it was using your SIG to do the type checking statically. But with Sorbet, because we're actually having those SIG artifacts in the code, you can also enable what is called runtime type checking, where you're going to check the type of things at runtime while it's running. This may not be something you want to run in production because there is some overhead. But when you're in development mode or on CI, that will be super useful to know that you're casting something to the proper type and you're not trying to lie to the static type checker. Because we changed those SIG calls into comments, there is no more artifacts that the runtime type checker could be using. So we're losing this runtime type checking, and that may be a problem because it's very easy to lie to the type checker and then you're actually having a type error that the type checker didn't find. We have a way to re-enable it using Ruby Next's require hooks. That means that at runtime, when you're going to execute your code, when you're going to load a file, require it, at require time, we're going to rewrite this file in the same way we did inside Sorbet when we're going to do it in Ruby to re-inject the SIG in your actual executed code. Disclaimer, do not do that in production. This is very, very not performant. But in development mode, that may be super useful. And so when you're going to run your code, if you need it to enable runtime type checking, we can rewrite this file and re-inject the SIG blocks inside your file. Everything I showed today is already live. You can see it by yourself. We already started migrating some of the gems that we own. So for example, the Ruby LSP, Tapioca, RBI already use this new RBS syntax, and we're in the process of removing the Sorbet runtime dependency from it. So you can already see how we went from removing the signatures, the annotations, translating the annotations and stuff. Spoiler alert is mostly running a tool to translate it automatically. If you want to learn more about it, you can also install the latest version of Sorbet and take a look at the documentation to see what are the different features and how it works, and get started in your code base. With this, I'm going to wish you a happy typing. And if you have any question, please find me. I'm the guy looking like this in the crowd. And if you're interested in working in those toolings, anything about developer experience, Ruby on Rails infrastructure, please take a look at the QR code here and apply. Thank you very much.